finish out chapter 5, we're going to look at section 5.2, which is the normal distribution. So the normal distribution is the most common distribution in statistics and describes many real-life data sets. Below you can see a list of examples. Just a couple to mention are SAT scores and heights of people. A data set whose histogram is bell-shaped is said to have a normal curve or normal distribution. The mean, median, and mode are all the same, which means it's in the middle. The highest point of the curve is at the mean. The curve is symmetric with respect to the mean, meaning if I fold this curve in half, it would be the same on both sides. Half of the data is below the mean and half is above, and the total area under the curve is 1. And here you can see a picture at the bottom. So the bars are your histogram, and when we're talking about the area under the curve, that's all of this under that red. And when you're thinking about working with a normal curve, it is continuous. So even though the data set histogram may look like a normal distribution, when you're thinking about normal distributions, you're thinking about this solid line of a normal curve. So there is a rule when we work in statistics, when we're working with normal distributions, and it is the empirical rule, and you may also see it as the 68, 95, 99.7 rule. So what this is saying is that 68% of our data falls within one standard deviation of the mean. Now remember, we said that this highest point is the mean, or mu. So I have my mean here, and then one standard deviation from my mean on each side. All of that is the 68%. So if you want to think about it as looking at it as a shaded region, so this kind of middle part here, that is your 68%. Now, where did this 34 and 34 come from? Well, if this is a normal curve and we do 68 divided by 2, because it is symmetric, then we get that 34 for each of those pieces. And then you go 2 standard deviations out. So 2 standard deviations out is from the -2 to the +2, and 95% of your data will fall within that region. So we know that 68 is here, and then we only have a total of 95. So if you do 95 minus 68 and then divide by 2, that's how you're getting that 13.5 for each of these green shaded regions. And then we're going to go one more step out, so that's 3 standard deviations from the mean. And 99.7% of your data will fall within 3 standard deviations of the mean. Again, if you do 99.7 minus 95, divide that by 2, you'll get this 2.35%, and that is what falls within that between the second and the third standard deviation. And then outside, remember that I told you the area under the curve is 1, so that means that all of this needs to equal 1. So all you have to do is 100% minus 99.7%, and then divide that by 2, and that's how you get those little tiny areas there at the end of 0.15%. So you can use that information on the previous slide to answer some questions. So if I have a data set that has a normal distribution and it has a mean of 10 and a standard deviation of 2, we're going to use that empirical rule to find the percentage of values that are below 10, below 8, and between 12 and 14. So the first thing you need to do is you've got to mark off what you have. So we know our mean is 10. Now every time you step down, okay, so when I go 1 standard deviation below, then all you have to do is mu minus 1 standard deviation. And then if you go down again, that's going to be mu minus 2 standard deviations. Mu minus 3 standard deviations. When we are going above the mean, we're going to add. So we're going to do the mu, or our mean, plus 1 standard deviation, the mean plus 2 standard deviations, the mean plus 3 standard deviations. So I'm simply just going to be subtracting when I'm moving down and adding when I'm moving up. So if I do 10 minus 2, I get 8. If I just subtract 2 again, 6, 4. When I'm moving up, I'm going to add, so 12, 14, 16. Now you can take that information and you can answer those questions. So the first thing says below 10. So if I'm looking at below 10, well, 10 is my mean. So if I'm looking at below, so that green shaded area there, 50% of our data should fall there because the mean is in the middle. If I'm looking at just below 8, so that's going to be that red shaded area, then you can think about this as a whole, and we know that the red is going to be, if you did like 1 minus all of this leftover part. We know that this is 50% and this is 34, so you could just do subtraction there. You could say 100 minus 50 minus 34. You can also add up these pieces here. So if you do 100 minus 50 minus 34, you should get 16%. And then we have between 12 and 14. So if I'm looking at between 12 and 14, so that is just this one area. I'm shading it yellow here. Then you can say, well, that is that 2 standard deviations above the mean, and you can just look back at what your normal distribution curve says between the first standard deviation and the second standard deviation, and that gives you the 13.5%. So here is a practice problem that I'm going to let you try. I want you to fill out the normal curve, and then you're going to use that to help answer the questions on the following slide. So this is going to be SAT scores of college-bound seniors in high school has a normal distribution. We are going to fill out just the mean, and I want you to just mark the standard deviations above and below with positive or negative 1, 2, 3. And then you can move forward. You can pause the video here and fill out the normal distribution and then come back and see it. And then when you move to the next slide, you can pause it again, and then when you're ready to see the answers, you can see those. So you can see the answers here, and we can also use this information moving forward, finding how much data may fall in that area. So here we're going to look at the distribution scores for 1,000 students who took a standardized mathematics test, and we found that it is normal. The mean is 450 and the standard deviation is 25. So we have a mean of 450 and a standard deviation of 25. So you're just going to go ahead and fill in those pieces. Okay, and then how many scores do we expect between 425 and 475? So that is within one standard deviation, and we know that 68% falls there, but this is how many scores. So you need to do what is 68% of the number of students, so 1,000. So you'll do 0.68 times 1,000, and you should get 680 students. And then we do the same thing for the next problem. So it says how many scores do we expect to fall above 500? So above 500 is this area. So that is 2 standard deviations above the mean. So if we look at between the 2 and 3, that is 2.35%, and above the third is 0.15%. So if you just add your 2.35 plus 0.15, you get 2.5%. And then you're going to do, well, what is 2.5% of 1,000? And that is 25 students. There is some practice in your textbook. You can do 1 through 11 odd, 47 and 49. And of course, your My Math Lab homework is your attendance assignment for this week. So make sure that you get that 5.2 homework completed. Let me know if you guys have any questions, and I will be happy to help.